Plastic is an important, widespread material of great use to society worldwide. However, a huge amount of plastic still ends up in our beautiful ocean. People are becoming more aware of the potential threats plastic poses to the environment and to human health. Are microplastics in our food dangerous? How much should we actually reduce our plastic use, and what are potential solutions? It's important to understand how plastic ends up in the ocean and what its effects are, so we can assess the risks and take measures to protect both ourselves and our environment. Let us take you with us on a journey to explore the ecology and the effects of plastic pollution in our oceans. Worldwide, there is an estimated 75 to 200 million tonnes of plastic waste in our oceans, with 8 to 12 million tonnes entering each year. Approximately 80% of marine plastic pollution originates from land-based sources, including improper waste disposal and runoff. Plastic poses a deadly threat to both natural and anthropogenic environments, since it can absorb toxic substances or stick to marine constituents such as sediment. Microplastics are microscopic plastics created from the breakdown of all plastics. They permeate into all parts of our lives and environments, from cosmetic products to the food we eat. Microplastics, due to their chemical nature and microscopic size, are absorbent, easily adaptable, and have a slow rated breakdown, meaning they may take thousands of years to disappear from and can permeate into any environment, impacting people and our environments for many generations. The impact of microplastics onto animals has been widely documented, with evidence of animals choking on, being strangled by, or entangled in waste. Microplastics adversely affect phytoplankton, corals, sea turtles, seabirds, and a wide range of other organisms, causing issues such as growth inhibition, digestive blockages, and even mortality. The ingestion of microplastic disrupts food webs and poses risk to species across all trophic levels, including humans who consume contaminated seafood or use microplastic-based products. Meredith E. Seeley, a prominent biologist, researches the effects microplastics can have onto microbial communities in aquatic sediments, with seagrass meadows as her primary example. Her studies have detected microplastics in seagrass meadows with concentrations reading up to 1,000 particles per square metre in certain coastal regions. The presence of microplastics can reduce light penetration in seagrass beds, leading to a 10 to 20% decrease in photosynthesis rates, impacting growth and oxygen production. Despite the widely known detrimental effects of plastic on human health, there is a severe lack of knowledge and research into mitigating the repercussions or causes of microplastics' impacts. Mainstream evidence illustrates that microplastic exposure or consumption can potentially lead to cancer, increased risk of heart disease, and pregnancy complications, threatening our current and future generations, since plastic effects can be chemical, physical, and/or biological. Microplastics have been observed to have inimical impacts onto all species cells, including and especially humans, due to plastic's presence in our blood, brain tissue, and inside some of our body parts, as well as their potential to mimic our own body's fats, with microplastics being discovered in the human body on a cellular level. Moreover, there is an extreme lack of research onto microplastics' effect onto human health, since there is no control group with zero microplastics in their system, meaning a large majority of microplastics' impacts are even hard to research and identify. Furthermore, avoiding microplastics is near impossible, since they're virtually everywhere in our environment, from our food and water to clothes and cosmetics, due to their absorbent and adaptive nature. Due to the large scale and lack of knowledge around our plastics problem, creating solutions to combat the causes and effects of microplastics is extremely difficult. An initial solution would be to reduce the plastics currently being produced, to diminish the inflow of new plastics and consequently microplastics into our environments and oceans. The implementation of efficient waste disposal and recycling plants would greatly help to reduce the plastics entering or collected from the oceans, giving them a new purpose and subsequently decreasing the need for new plastic production. Moreover, the increased movement from plastic products to more sustainable and biodegradable alternatives will further reduce plastic production and waste. These mitigation strategies can be enabled through government policy and legislation, and has been initiated previously, such as through the banning of single-use plastic bags and straws by the West Australian state government. Conversely, the introduction of more marine and national parks, as well as stricter laws around anthropogenic activity within these zones, such as leave no trace and restricted activities, could also reduce the plastic introduction into specific biodiversity concentrated ecosystems where plastic has had the largest impact. Additionally, we asked researcher Anna Faber for her impact on our plastic struggle.
So what can we do as students, lay people, and academics like yourself do to try and displace and disempower some of the systems that rely so heavily on petroleum-based single-use plastic?
Yeah, it's definitely a team effort. So it's not only industry, it's not only policymakers or academics. It actually needs to involve everybody. We need to come together to make a positive change. And I always use my 5 R's: reduce, reuse, and recycle. Having a lot of great materials we have been using for thousands of years, like glass and paper, that actually can be reused much more practically, but also we really need to make sure that we use them in a sustainable way, because we can also create a lot of waste with that. But we also have emerging new materials such as biodegradable bioplastics, and our lab, the Fritz lab at UWA, is actually also working on that. So we're making bacterial fat, can extract that fat and we use it as a plastic alternative. But if we litter that into the environment, this can actually be degraded by the bugs, because they made it in the first place, so they also know how to chew it down. So I think it's really in its infancy. It's developing really fast. So we have labs all around the world actually starting on plastic degrading bacteria. And I assume that it's going to be quite relevant in the next 20 years, and hopefully we see its impact developing with startups coming out of research. And we already have a few startups on plastic degrading bacteria in Australia and worldwide. So I think it's really an emerging field.
Thank you so much for your time today.
You're welcome. Thank you.
Plastics are an incredible invention and have had and still have many necessary uses throughout society, such as sanitary medicine supplies, building materials, and kids' toys. However, the detrimental impacts plastics, especially microplastics, have onto people and the environment need to be mitigated, since the health costs potentially outweigh the societal benefits.